An electric scooter. Very nice. Beautiful. Here's a little battery in there, and here is you. Handlebars are a bit high for you there. But you are traveling down a straight footpath. And the velocity after passing a sign is given by v of t equals 0.3 t squared plus 1, all right, in meters per second. Now, how far have you traveled from the sign up to the point where you've traveled for 3 seconds? All right, so we are given the velocity function. We are looking for a distance, right? Far meaning a distance. So this is a kinematics problem because it's dealing with motion. And for a kinematics problem, we can relate distance, velocity, and acceleration through calculus, right? So the rate of change of distance, in other words, the derivative of distance, is velocity. The derivative of velocity is acceleration. And conversely, the antiderivative of acceleration is velocity, and the antiderivative of velocity is distance. So in the question, we are given velocity, and we need to find the distance. So we can anti-differentiate our velocity function to find it. So velocity is given. We are looking for the distance function. Right? The reason why we want the distance function is so that for any time we can work out the distance. So the antiderivative of 0.3 t squared is 0.3 t. We add 1 to the power, so that becomes to the power of 3. We divide by the new power. The antiderivative of 1 is 1t, in other words, just t, right? And that's because what's hidden there is 1 times t to the power of 0, because t to the power of 0 is 1. If we add 1 to the power, it becomes t to the power of 1. We divide by the new power, and we don't need to write those ones. And finally, the antiderivative of 0 is some constant, right? We don't know what this constant is, but whenever we anti-differentiate, we need to write in plus c in case it is a non-zero value. So just simplifying that a bit, I'll just do it in one line. So 0.3 divided by 3 becomes 0.1, just to clean it up. All right, so we found the distance equation. What's our last step? Well, they're wanting a distance for time equals 3 seconds. Now, actually we haven't found the distance equation yet, have we? Because we have this plus c. So before we can solve for distance, what would plus c equal? So this plus c means the initial distance from the starting point. And since our starting point is at time 0, our distance from that is 0, right, when we start. So the distance when time is 0 is 0. So therefore, solving for c, it's apparent that c is actually just equal to 0, right? We have no initial distance from the start line. So our distance equation is simply 0.1 t cubed plus t. And that condition that your starting distance is 0 at time equals 0 is often hidden or like implied in the problem. So just write a equation like that to show that you've understood that. Or in words, you could say starting distance of 0 meters. Yeah, that's equivalent. All right, now we can finally solve, right? Substituting in 3 seconds for time to solve for distance. So the distance at time equals to 3, is 0.1 3 cubed plus 3. 3 cubed is 27. 27 times 0.1 is 2.7. Plus 3 is 5.7 meters. That would be our final answer. And this is an achieved question because we anti-differentiated. Solving for C was, I guess, trivial in the sense that it was 0, right? The initial distance was 0. However, you do need to know that. And then finally substituting in a time to get a distance. So after 3 seconds, you have traveled 5.7 meters.